Good evening, everyone. Are you able to hear me?
Yes, ma'am.
Okay, great. So, this week we'll be discussing week 11 questions. Before we do that, how was week 10 assignment for you?
It was okay, ma'am. I got 70 marks.
Okay, nice. How about you, Shinag?
It was okay, ma'am.
Nice. Okay. So, any doubts over there from week 10? Okay, so looks like that one was good. Let's
Ma'am,
move ahead to.
question five,
Okay.
uh,
All
which
right.
was so long. Okay, that was wrong for me.
Mm-hmm.
Question 5. Do
This
you
one?
have
Oh
that
no.
answer?
3, 4, 5. This one?
Yes, ma'am.
Hmm. The rest of them were correct. Only question 5 was wrong.
One is question 5,
Mm-hmm.
which was wrong, and then one question 8 is also wrong, ma'am. And then
Okay.
question number, what you say, this one is what? Ninth, I selected one wrong option. One is right. Two options to be selected. So so they have given 0 marks. So in
Okay.
ninth also that marks is 0.
Hmm. Others were right.
Yes, ma'am.
Okay, nice. So,
Similarly, question number 1 also, there is a very less difference between A and D. So I marked A. So answer is D.
yeah.
That one is clear. No, that is not an issue.
But you had to do this way. Okay, fine. It was more about a typo from your side. Okay. So, Shivang, what questions were wrong for you?
Hello,
Yeah. Tell me.
ma'am. Ma'am, your voice was not audible. Now it's audible. What were you asking?
Yeah, yeah. I was asking that which questions did you miss out, or were everything right for you?
Ma'am, I was just confused based on the expression just in the first question.
Mm-hmm.
Otherwise, everything was fine.
Okay. So, but was this expression not right?
Uh, Maybe I applied it. I mean, it was very confusing looking at the diagram that what is one W121 and what is W112, etc. So,
Okay, okay.
so just this question I got wrong. Otherwise, it was
Hmm. Okay, you're saying this one is the right option. Which one was the right option? A or D?
D was the right option.
Okay. Hmm. Shouldn't it be the opposite?
I marked A, ma'am, and that the answer is D. So I got 0 marks in that.
So this one is
Actually,
zero point 0.5.
initially I also thought that it should be opposite, but if you go to the section, if you go to the question 3, then
Yeah.
you will find out that if we apply the formula that you instructed and the normal formula, then the
Mm-hmm.
answers wouldn't come in all four options. So I go
Oh, okay.
I have gone with the difference. For example, you have taken the W1 as 0.1, 0.3, 0.4, 0.4,
Yes,
but
yes, right.
also be opposite. Then only we get to the any options answer. All four options were not there. So that's how I got the idea that it should be opposite.
Okay. What is it there in the lectures? Because, I mean, these kind of things you should raise. Week 10, right? Yeah, it's here. Oh, okay. It is like this. So W11, then W12, 21, and then 22. This is what I wrote over here, right? Um, Sorry. W11, 12, 21, and 22. Hmm. I think they should give marks for both because they didn't give you an option over here in question 3, right? Based on whatever is the correct answer, and then that also happened. So, Anupam, were you able to get the correct answer for this one? Number
Which
3?
one? Which one, ma'am?
Number
Three.
3? Yeah.
1 minute, I will see.
Okay.
Yes, ma'am. Three. The answer was correct.
Okay, then how did you solve it? What was the value of W1 that you put over there? Do you have the solution handy with you?
Just now I am searching for that. I have a solution. 1 minute, ma'am.
Okay. So Shivang, but you were able to figure out that this one is like the wrong choice, right? Eventually,
Yeah, I
or
was able
did you
to
not
figure
change it?
out, but I just got with the I just
Understood.
go with the formula. That's why.
Yeah.
So, according to your formula and other papers also, I looked into the paper that was given in the references. The formula was
Mhm.
correct, and it should be like that. That how the neural network is structured. But
Right.
I guess I think the linings also, for example, the in the diagram W112, maybe
Mm-hmm.
this is for the there are two lines crossing, na. So maybe this
Yes.
is for the other one, and that can be the case also, na.
It doesn't matter. I mean, I did not refer the diagram. If I refer over here, that's it. The values are given over here, no? So you cannot confuse with that.
Yeah, but I think
Mhm.
according to the, I think they have done exactly opposite in all the questions, in one third and
Uh,
also in the fifth.
Sorry,
Okay.
good evening, ma'am. Sorry for the interruption, ma'am.
Good
Ma'am,
evening.
in the forum also for the first question, what the answer they have given for what we have chosen, it is opposite, ma'am.
What is in the forum? Sorry, your voice broke off.
Ma'am, 1 minute, ma'am. We have chosen
Okay.
the option as A, ma'am, but in
Yes.
the solution they have given the option as C, ma'am. C or
D. D.
yes, ma'am.
Hmm.
And for third problem also, they have solved. They have not solved in the manner what you have explained in the last week session, ma'am.
So, what is the reasoning that they gave for choosing this and not this?
Ma'am, in the forum, I think one person have informed that the A option is the correct, and they have given the reference as the lecture slide, and they said that answer A is correct. Whoever chosen the answer A, the answer that will be chosen as the correct answer. They have given us a reply for that question what they have asked, ma'am.
Okay. But you all should say, right? Like mention that slide in slide 8, this is what is there.
Ah, yes, ma'am.
Okay, so try to tell that.
Okay, ma'am.
Okay?
So for,
Yeah,
I think
because
previous
Mhm.
week also there is one question that is first question they have raised as an that error, ma'am, that positive definite and positive semi definite for that question, ma'am.
You mean week 9?
Ah, yes, ma'am. Week 10, I think. This week 11. Ah, yes, ma'am, week 9. Mm.
Which question?
First question, ma'am.
Yeah. No, here it was symmetric and positive definite, right?
Ah, yes, ma'am. But in the solution, they have given like symmetric and positive semi definite.
Is it?
Ah, yes, ma'am.
Oh, you guys actually should show the exact slides on which things are written. Okay?
Yes, ma'am.
Try to put that in the group. I'll also try to join the forum and see if I can help you all. Okay?
Yes, ma'am.
All right. Okay, so this one is actually debatable. So number two, yeah, Anupam, you were looking at your solutions. Were you able to figure out what you used here?
I'm actually I'm not able to find where I have kept that. Sorry, ma'am.
Okay. No worries, no worries. Okay. So as Shivang said, I think by flipping I think these two values, he was able to get the answer. So probably that is how it's coming along for now. You need answer for number 5. So number 5 was simple, right? I think alpha I had put, these things we had put. What was remaining? So number A I had actually solved. So it was this value. So what did you, like, whoever has solved? So Shivang, you had solved, right? What is the value that you get over here? And Padmavati, were you able to get all the answers right?
Ma'am, for me, the third and fifth, I also got the answer as wrong. One of
Okay,
the
okay. Then probably because of this switch. Yeah. So Shivang, could you help me with this? Are you able to hear me?
Yeah, ma'am. Just I am opening my solution.
Okay. What is the answer for question number 3? Which option is right?
0.59 and 0.62.
C is the answer.
Okay, 0.59, 0.62.
Ma'am, can you please solve that question 3, ma'am?
Okay, you want me to solve that first? So here it was simple. The only thing probably was confusing is this swapping part. So maybe because Shivang got answered using that, I'll try to put those values over here. So the first one is actually like this: 0.1, 0.3,
And
0.2, 0.
your slides are not visible today.
My slides are not visible.
Yes, ma'am.
Is it not visible for others also?
Ma'am, I can able to see your slide, ma'am.
It's
Anupam,
visible,
could you
ma'am.
rejoin once? We'll
Okay.
wait for you. Yeah.
Ma'am, why you have swapped the values, ma'am? The 0.1 and 0.2 and 3 have swapped the values.
Because over here I have written based on what formula is given in the slides. Okay.
Okay.
But based on what you all are saying, that they have given a solution based on the opposite thing. So I did this. Correct? And this is based on the slides. But I think in the solution, what they have used is, they have used like this,
Yes, ma'am.
right? That's why I swapped, just to tell you how the answer is coming along. Yeah, I think he's here. Can you see the screen now?
Yes, ma'am.
Okay, nice. All right, let's continue. So when we multiplied these two and then added the 0.25 and 0.25, what was the answer that you got of Z1?
0.37 and 0.51.
Okay. And then we passed these two values over here in the sigmoid function. So basically the first value is going to be 1 by 1 plus e to the power minus 0.37 and 1 by 1 plus e to the power minus 0.51. So what are these two? So Shivang, I think you dropped for a while. So
Yeah,
what are
yeah,
the
yeah.
answers to these two? Huh.
0.59 and 0.62. That's the answer. If we put directly, and that is what we have to put. That is what is the answer also.
No, 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 no. Actually, over here something else would come, right? And then that goes over
No,
here.
no, 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 no. Actually,
No.
it is asking what is the output for the second layer. For example, the second layer.
Okay,
I
values
also,
passed to the output layer. Okay, okay.
yeah. So output layer will give the A2 na. So that's
Yes.
why I think,
Right. Okay, yeah. So
like,
we did not have to do all of this.
yeah, yeah,
Yeah,
yeah.
my
And
bad.
also,
Sorry, sorry about that.
yeah, 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 yeah. And
So this
also
in
we can
itself will
we
be
can get,
0.59 and 62. Haha, tell
yeah,
me.
we can get the idea. For example, if we go ahead, then we
Mm-hmm.
can't find anything from the option, so we can get the idea that we should go with 0.59 and 0.62.
Right, right. No, you're right. So this was actually find out the values passed to the output layer.
Yeah.
Yeah, correct. Yeah, that is good. Good catch over there. So this was not even required. So Padmavati, is this fine?
Yes, ma'am. Thank you, ma'am.
Okay, no problem. So since 0.59 and 62 is the answer in this question number, so actually over here use the value of A1 from question 3. Uh, 0.59 and 0.62. So first of all, this is given, this is your target. Sorry, this is your actual and this is your target. So we are trying to do this. This is our lost function. So we calculated this dou f by dou a11, which is for this terminology. And over here we have q1 as my 0.15, which is this, and a11 is 0.73492, which is this part, right? This and this. We are trying to work on those two. So what is the value that we got over here? So minus 2 into 0.15 minus 0.73492. What is the value for that? I think either of you can calculate and tell me. Yeah, somebody unmuted.
1.16984.
Okay. Now we want to do dou of A11 divided by dou of N12. So what are these two things? So I think A1 is that your sigma part, right? So whenever you differentiate your sigmoid function, this is how it comes up. So that is the like given formula for that. I mean, you can derive it also, and it comes like this in this format. So you do 0.73492 into 1 minus 0.73492. What is the value for that?
0.19492.
Okay. So now we have this as our equation, right? And over here we wanted to do dou of n21 by dou of w211, and that gave you a1 square. So this is what we have to get from q3. So let's see, what was the value over there? What value did you take over here?
0.5, because you already told. I think you can move the slide a bit o- down, down where it is written. Yeah, so you told now W110 is equal to 0.5. So
No, w110 is that. What did you take for this part? That is your initial weight, learning rate, and then you have to do a into b into c.
yeah, yeah, yeah.
So
So I
what value did you take over here? I think it should have been a21, which is your output value. But let me just check once again. Hmm. Did you happen to calculate further ahead after this? Like the
yeah, yeah,
output?
I calculated, but it's
Hmm. A1 square. Use the value of A1 from question 3.
0.59.
Okay. Square of that, right?
No, it is
Okay, okay.
0.5.
Sorry, sorry.
That is not a square, no, that's
That is the
convention.
first one itself. Okay. Let's see. So what is the value of D now? It should be 0.59 into 0.19492 into how much? 1.16984. What is this value?
0.134.
0.134. So over here we should get 0.5 minus 0.25 into 0.134. So what is the value of that?
0.4665.
0.4665. I think the closest is 0.47 then. Is that the answer?
Yeah,
Okay. So this is how I think you were supposed to go. Is this fine with everybody? These steps?
yeah,
Yes,
ma'am.
fine.
Okay. Okay, so I think next is number 8 and number 9. So number 8 says which of the following statements is correct regarding the control barrier function when designing a safe controller using a neural network. So the CBF must remain positive inside the safety region to ensure safety. So before that, when we used to talk about this circle and all of that, so what is the value of barrier function inside the circle? Is it greater than 0 or less than 0?
Less than 0 actually.
Okay. And outside that it is greater than 0, right?
Greater than 0, yeah.
So CBF must, and inside is your safe region and outside is your unsafe region,
Unsafe reason.
right? So CBF must remain positive inside the safety region to ensure safety. This is wrong. The rate of change of the CBF must be positive inside the safety region. So inside, if your B is less than 0 and if your rate of change is positive, which means that it is going to increase. So even if your B is like, let's say, -5, it is going to increase, then it becomes +5. So it actually is going towards the unsafe region.
Unsafe reason.
Yeah, so the rate of change also has to be negative. Okay, so CBF must remain negative inside the initial state space, and your rate of change of state must also remain negative. So this should be the right option. And this is what also from question 8 of week 9, if I look at this, what did you select? So over here, we selected, right? Bx decreases.
Gradually
Okay,
steering the system towards safety.
right. So your Bx is also less than 0 and your B dot x is also less than 0. Right? So this is what is the right answer. Is this fine, Anupam? Did you understand this?
Yes, ma'am.
Okay, nice. And then the last one is this. So which one of the two did you get wrong? One is about this eigenvalue, and one is about this rate of change of CLF, I guess. Yeah. Are you checking that, Anupam?
Yes, ma'am. I marked A also, so that is why I have given. Yeah, but A is not the answer.
What all have you marked?
I
You
marked
have
A
marked
and D.
A
A
and
and
D.
D. Yes, ma'am. The answer is B and D.
The answer is B and D. Okay. So one of the, so this portion you got correct, right? About this change of rate of change.
Yes.
So the first one is the problem. So here it says that it should penalize the agent or it should reward the agent. So do we need the eigenvalues to be equal to 0? It should approach 0 inside the state space. So yeah, I think this was there, right? So if you have to go to your, I think, stability or something like that, your closed loop state transition matrix should approach 0. So this option was also true and this was also true. So that was one condition. That's why I wrote the first one as like whatever it was the right option, I wrote that first. And here it is like if you want it to approach 0, then it should reward the agent, which means that you are supporting the agent to get to that answer. Okay. I think it was more of a minor mistake from your end. Okay. So let's move forward. Shall we discuss week 11 now?
Yes, ma'am.
Okay, great. So let's see. Yeah, this week again is very numerical, but it is also based on coding. There are a few questions based on coding in MATLAB. So if you have that IDE, that would be good. So the topic is state estimation using Kalman filters. And I think the first two questions are theoretical, so I'll just go with it. So here the question says state true or false. Kalman filter is optimal when all the noises are Gaussian. Okay. So first of all, you should look at the design of Kalman filter, that how it is being designed. Okay. And when we consider the design of Kalman filter, what kind of noise sampling do we consider? Okay, so from where is the noise sampled from? So what kind of distribution is that? And if the noise sampling for Kalman filter itself is picked up from some kind of distribution, then it is going to help it, right? So it is optimal when all noises are Gaussian is true only if your noise sampling this is from Gaussian or not. Okay, so you have to check that in the design of Kalman filter. So if in the design it says that the noise itself is being sampled from Gaussian distribution, it will be optimal when your noise is Gaussian, right? So you have to check that part over here. Okay, this was simple. Yeah. Next question says, let the residue be the difference between estimated and actual sensor measurement. So this is your residue, this is estimated, and this is actual or maybe observed, either of that. Okay, so in general, and you also say that, right, that there is some kind of error. So what is error? Error is like ideal minus what do you get, like practical thing. So ideal minus observed, either of that. So for any kind of control system, what do you want to do? You want to reduce this to 0. So with the same concept, what does Kalman filter try to do with the residue? That you will have to check. So over here, let's say if we go through the slides also, um, yeah, so it tries to minimize some kind of mean square error of the estimated parameters, right? And what is your mean square error? So you will have to check that part. Okay, so I would say refer slide 5 and you should be able to get your answer. Same over here also. Okay, this question is again from the lecture itself. It says, consider the figure of the closed loop system with an estimator in place given below and fill in the blanks. So this is your open loop plant. This is your observer. Okay. So now there are a few things over here. This K is actually your controller gain. So this is your controller gain. This is your estimator gain. Okay. So since over here you have your observer and that has a perfect model, that is fine. But over here we have this as gain over here and this is one gain over there. So now every step that you see, let's say from K to B, you sent UK. What is in general UK? What is U represented as in control systems?
Control input.
Control input, correct. Okay. So these are the steps shown over here. So if I say that UK is going to be, okay, if I just zoom in, and then this is your X of K plus 1, right? So this is going, and from here something is coming. And what is coming over here? Which is XK. All right. So XK into A is coming over here, and then this is getting plus. So these kind of equations are going on. And then finally you get YK. What is YK represented as? What is Y in general?
Control output.
Control output, correct. Okay, so based on that, there are some equations written over here. So if I look at the first one, which is YK is over here, correct? So C into XK, which is this, plus V of K. Where is V of K coming from? Okay, we'll get back to this one. And y hat of k is coming from here, which is your observer model. It is c x cap of k. So c into x cap of k, right? So it is that simple. These are the equations. And then over here, if you try to calculate what is coming over here, it should be y of k plus y cap of k, right? Because both of them are getting plus over here, right? What more can you do? So over here, it will be L of yk plus y cap of k, right? That goes over here, and then you are doing a plus again. So these are the different kind of things going on. So what is the question? The question says k is control gain, okay, that we have uh, gotten through. L is your estimator gain, rk, vk, and wk. So rk is reference, vk is measurement, okay, got it. And process noise is your wk. So these are the values, other symbols follow usual meanings. All right. So over here, since v is not given, v was your measurement, and w is your process noise. Hmm. So now what do you have to fill in? You have all these different equations of uk and x cap of k plus 1 that you have to fill in. All right. So depending on the flow of the values, you will just have to calculate and put it in there. So u of k, you will have to check that what is coming from here, right? And what are you trying to subtract? Okay, so you will have to multiply k with this value that is coming over here. So it will be rk minus something. What is that something? That something is your x hat of k, right? So this is what is coming over here. And the same thing is going over here also, x hat of k, right? So you will have this will be in plus and this will be in minus, and then they will be multiplied with your k, right? So that is the kind of mathematics you will have to do over here. It's a very simple question. Okay, and similarly, what is your x hat of k plus 1? That is going over here. So 1 is plus coming from here, and 1 is from here, but what is coming from here is 1 and coming from here. So there will be something of b, which is given already, b of u of k. So u of k is coming all along. So b of uk, and then you have to multiply, you have to add this also, and then you have to add this also. So a of x hat of k. So it is like that. All right, and this same thing is also in your slides, which is right over here. Okay, so I think slide number 6. Is this question also fine?
Yes.
Okay. Next question. So from here until the ninth question, probably most of them can be solved using MATLAB. I'll try to go through each of them right now, but in the end, I'll also give you a code that is going to help you solve these questions. So try to also work on the code so that eventually it helps you in the final exam, or like in general understanding how control systems work in MATLAB. Okay, so consider the continuous time state space model of a electronic stability program control system. Your x dot is given, and what is this formula actually? This is a of x plus b of u, and y is equal to c of x. So basically a, b, and c are given for you. All right. The two states of the system are side slip angle and yaw rate of a vehicle by controlling the steering wheel angle. Okay. Among two states, only yaw rate is the measurable output. So your x is actually like this. So the first one is what? Side slip angle. And this one is yaw rate. and your U is actually steering wheel angle. Okay. So among two states, only your rate is the measurable output. Complete the following MATLAB code to discretize the continuous time state space model with a sampling period of 0.1 seconds. So the code is already given to you, but you have to check that which functions actually help you. So in general, if you want to just know what some commands do, in MATLAB, you just need to type help and the command name, and that will give you what kind of parameters it takes, what is it used for, and what values it can like are feasible, and those kind of things. Okay, so over here it says sampling period is 0.1. Okay, so TS is 0.1 is already given. So let's start from the beginning. Your A is given already, 0.5 minus 0.05, 1.3 and 0.4. This is your A. Your B is also done. C is also initialized. Sorry, C is 0 and 1, and D is 0. Okay, and then you have your sys C, which is your continuous time state space. Sys D is discrete time state space. So these are the two things. Sys C is given as SS A B C D. Okay, so you should also do help SS just to understand what that command means. And then you initialize your model over here. Then your TS is equal to 0.1, which is already given in the question, a sampling period of 0.1 seconds. So sys D, which is the discrete time state space model, which of these commands are going to help you get the discrete time state space model? Okay, so since in the question itself you have SS, which is giving you continuous time state space, so definitely these two won't be your answer. Okay, you will have to check with within these two which one is the correct option, and to do that you should go do help. I would just write that it should be C to D. So try to know what this command means and then try to choose the answer for that. So you, when this command is done, it will also tell you what kind of parameters it takes in, because the parameters are different over here. One is taking A, B, C, D, and one is taking sys of C. Okay, so you just check that part and try to answer this question. Should we move to the next question?
Yes, ma'am.
Okay. Okay, exactly the same question from there. Continuing from question 4. Complete the following code snippet to design a discrete time LQR controller gain. So right now we are trying to work on this K. Yeah, help function name in MATLAB. This is what I was talking about. To know its definition, sysd is the discrete time state space model derived in question 4. So sysd was what we got over here. Let's say we got it. Okay. So sysd dot a, what does that mean? So this is your discretized A. Then B, sys D dot B will be discretized B, and so on. Okay. So you got those four matrices or arrays, whatever it is, in the discretized format. And Q is equal to I size A2. Does anybody know what I is used for? Any guesses?
Identity matrix, no?
Identity matrix, correct. Yeah, that is good. So your Q is an identity matrix of size 2. And similarly, R is your identity matrix again. So this one is your weight matrix for state, system state, and this one is your weight matrix for control input. So the question is asking you K, S, and E. I think S and E will be asked later, or it's not. Okay, it's not being asked. So there is one command over here that is giving you discrete time LQR controller gain. It is actually giving you different kinds of gain, but yeah, you need to know that which command over here is actually getting you the discrete time LQR and what is the format of that. So basically what you do is go to MATLAB, type help, type each of these commands. So there are basically two distinct commands. Do LQR and do help of DLQR and see which one is giving you the correct answer. Okay. Yeah, the next question is also exactly similar. So you have some initialized matrix and so here A, B, C, D are from the previous questions or sys D is also from the previous question. Okay, just R1 and R2 are being initialized over here. So the question says which one will give you discrete time Kalman gain. So try to get that one. Hmm. Again, these are more about these questions are more about so that you know how to run these codes in MATLAB and to understand what these commands do. Okay, coming to the next question. Kalman gain L is computed by recursively solving the following two equations until the value of L saturates to a fixed value. Okay, considering the same system setup as given in question 4 to 6 and the initial value of the estimator error covariance matrix P, compute the value of discrete time Kalman gain L after 4 iterations. Note that the I function in MATLAB generates identity matrix and size A1 returns the number of rows of matrix A. All right. So basically what you should be doing is whatever code you have from here. So start coding, okay? Initialize your A, B, C, D, sys C, model, TS and sys D. These all you do over here. Once you are done with the first question, write these lines of code and after that write these lines of code. Okay, once you have all those three in the same piece of code, then you try to write down these two lines also. Okay, so you have L is equal to, you should write in this format. Okay, A P C transpose multiplied by this inverse, right? Inverse of R2 plus C into P into C transpose, and then you have P which is equal to A into P into A transpose plus R1 minus L into C into P into A transpose. Okay, but over here what should we do? We have to do for I is equal to 1 to 4. Okay, and then you will do end. And here what do we have to check? We have to check the value of discrete time Kalman gain after 4 iterations. So you will do DISP display of L. All right. Yeah, you also have to add this line of code before this. Okay, because size of A comma 1. So whatever code is given to you, try to put them in a single code and try to run that. It will work because A is already given, P is given now, C is you already have. What is R2? R2 you are getting from here. Okay, C, P and C prime. Now A, P, A prime. R1 is also from the above question, and L is actually from this question. Sorry, L is actually from above. Yeah, this same question. And then CPA. So this is what you will have. So at the end of fourth iteration, whatever it is, you will do a display of L. Okay, that will give you the answer. And similarly, the next question says what will be the value of estimator error covariance matrix P after 4 iterations. So since we are calculating P also, if you do display of P, you will get, this is for question 7 and this one is for question 8. Okay, so the same set of code will give you the answers for both. Okay, because this one is also talking about 4 iterations. Is this okay?
Yes, ma'am.
Okay. So the next question, consider the closed loop system with an estimator in place and the sequence of system state update equations in question 3. Given the same electronically stability program system in question 4, the discrete time LQR gain derived in question 5 is this, and steady state Kalman gain is this. Okay, so in those questions, first they were asking you the code, but over here they are giving you the values also. 0.2313. Okay, and L you will get something. If the reference is 0 and the initial value of system state is X and the estimated system state X hat, then what would be the estimation error of the ESP system after 4 iterations? Process noise and measurement noise is 0. So we are actually trying to work on this question 3. So we worked on this diagram, this one. Okay, we are trying to get to use all these equations from here. So let's see what all I can help you with. So X is given as what? 0.4 and 0.4, and X hat is 0, 0. And your estimation error is what? So for I is equal to 1 to 4, you're gonna write a few set of equations. What are those set of equations? Let me just copy from here. Mm-hmm. Yeah, I think this is fine. So you will write these equations. Okay, yk is equal to 6 c of xk plus vk. Vk is 0 because your measurement noise is 0 and your process noise is also 0. So your wk is also going to be 0. Okay. You have your x hat of k, which is 0, 0. So basically this one is also going to be 0, 0 for you. And u is given as what? Is u provided anywhere? Okay, you will have to get the equation for it. So basically you will get based on your x only. Yeah, so I think if you do all of this, in the end, what do you have to do? You have to get the estimation error. And what is your estimation error? You will do a display of x minus x hat, or you can do these kind of variable names also. Okay, so yeah, I think y is done. Y hat you will get, u you have, and x hat you have, then x of k also you have. Okay, so this is also fine, so you'll be able to get that as well. Yeah, so I think after 4 iterations, this is the value that whatever you get over here is what is your answer. Any doubts over here?
No, ma'am.
Okay. Yeah, the last question says which of the following MATLAB commands computes the controllability matrix? Again, do the same thing. Help, command name, whatever is the one that calculates your controllability matrix, it will show up. Okay, so this one is the easiest one, I believe. Um, yes. Any other questions? Like, let me know. But I'm trying to get the code for you. We can just go through the code and try to make it work.
Ma'am, how this question will be framed in the examinations? I can't understood the MATLAB ones.
They should give you a MATLAB editor.
Okay.
Hmm. But still, just to be like cautious, send them an email and verify.
Okay.
Yeah.
I think now NPTEL is becoming too big. Okay, they don't respond about the email now. This is
Yeah, I think there are
this is my
some.
personal, okay, what you say, comment.
Okay. Hmm.
I've,
No,
I've
it is, I mean, genuine, right? Like there are so many participants, so it might get tough also at times.
I've written 7 to 8 mails, but about exam, but no, they have not responded also.
Okay, they actually responded on this one saying that it won't be possible.
Okay, okay, then I don't know that.
Yeah, today I sent them an email on top of your email that you sent me, right? So I sent them a like a long email. You can check that. Okay, let me check if I can do something on the MATLAB online. Yeah, so let me share my screen again. Are you able to see my screen?
Yes.
Okay. So what I'm going to do over here is just give you a brief idea of how you should be going with your code. So I don't have the thing. Just a second. Let me transfer it on my laptop. Yes. Do you see my screen now?
Yes, ma'am.
Okay. So what I'm going to do is, since we just talked about all of this, let's see, is this, can we copy it? Oh God, okay. Okay, no problem. Let me just split my screen and I'll just type it. And then we can share it out also. So, yeah. So let's see. So what did I start off with? I said we have to initialize our matrices, right? 0.5000. And this is not like an actual MATLAB editor. I'm just having an online editor. Okay, then this is my B, which is 0.0500 and 4.5000. C is 0 and 1. D is what? 0. So sys C is equal to SSA, comma B, comma C, comma D. And then we do model. Sys D is equal to something, let's say. For now, I'm putting 1. So wherever there is this thing, I'll just put 1 each. Okay, and then you have to initialize your thing. So now your A is going to be sys of D dot A, because now you have discretized things. Size of A comma 2 R is equal to I of size of B comma 2. Okay, and then you have K, S, E. Again 1.
No, why one? Why one?
Because you have to answer that question. So I'm not going to put the code over there. Okay. So I am putting 1 like a placeholder. You have to put the answers over there. I'm writing a template, code template for you. Okay. Get from answering question number 4. Okay, and then over here we have to get from answer to question 5. And after this we have P, which is I of size a comma 1, and then R1 A, then R2 is I of question 6, KEST L E M N Z. Again 1 I put just so that the code doesn't break. Yeah, and after that P is already done. So now L you have to write. So L based on what I put in the text, like I'll be uploading the PDF also. So you can put it that way. So this is going to be A into P, P into C transpose into R2 plus CP C transpose. Okay, this was inverse of that. And then you have P. P is equal to AP A transpose plus R1 minus L into C into P into A transpose. Okay, I think this is fine. So now you have to write this for I is equal to 1 to 4 iterations, right? Okay, these two actually go inside your iterations. And then what do? Disk of L was this question, and disk of P, that is your next question. Okay, and after that what is it over here? Given the closed loop system. Okay, so the K we already get from here, right? So whatever K you get from here, you have to verify if those two are the right answers. Okay, whatever L you get from here, you have to verify that this is the right answer. Okay, now you put X is equal to 0.4, 0.4, and your X hat is equal to 0, 0. Anything else that I missed?
X
Again,
and X hat. x and x hat, we have to transpose it, no?
Yeah, that's why I wrote the transpose, right? I mean, this is in the that format. Um, these are two rows actually. Okay. Can I run it? It might throw an error. Let's see. Yeah, it is throwing an error over here. SS. Let me just finish the code, then I'll show you. So now we had to go back to this equations. Again, you do for I is equal to 1 to 4. Y is equal to C of C into X. Your Y hat is equal to C into X hat. Your U is equal to something you will put based on your equation. So I have put again over here. Question 3. Yeah. And after that you will do X hat is equal to A of X hat plus B of U plus L of dot dot dot. L dot 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 from question 3. And then X is equal to A into X plus B into U plus WK is 0 anyways. So this is your end. And what do you have to display? Estimation error. Estimation error, yeah. So disp of X minus X hat. So this should be your code, okay? So you have to substitute something over here based on whatever you get. You have to substitute from question 5. You will substitute from question 6. You will substitute over here from question 3. This and this. And yeah, that should be your overall code. And help command is actually used like this. This is not Octave, this is Python. Control AC, just copying in case. MATLAB is not an option over here. Okay, no issues. So what I'll do is I'll just share this code with you, and you all can copy it for time being. So are you able to open this link that I just shared?
Yes.
So please copy that code and paste it in your local editor, like a notebook or notepad, something like that, because it won't be available after 24 hours. It's a temporary link. And I'll just try to open one MATLAB editor because I wanted to show you how to use that help command also. Yes, I think it is working. Let's see. You can do help of let's see if I want to know about this SS, right? So I will type SS. You execute it. Run. Yeah. So it says state space model. Use SS to create all of this, and this is the syntax. So it says SS of ABCD or ABCD times, I mean the frequency also. So this is the full explanation of input arguments, sample time, because we used sample time also, right? So this is what is coming from here. SS. Simply you do C to D also. Okay, so if I just to help you, C to D if I put, if you do a run, you will know that it converts the model from continuous to discrete time. And what is the syntax of using it? Okay, so you will have to figure that out. So use this help command a lot, and that will help you get the answers for the most of the questions. Is this fine with everybody? Any more questions in these? Any doubts in these questions?
No, ma'am.
Okay, so just for the sake of, like ease of your efforts, I'll try to upload that code also in the Google Drive so that you can get help from there in case the link expires. Okay, so I'll be around until 8 p.m. But yeah, we can officially close the session. We'll meet next week, and next week is our last session. That is the week 12. So if you all have any request that I should take up this topic in the next session, we can try to do that also. So this is my email address. Try to send me an email by maybe next Wednesday or Thursday so that I can prepare whatever you all want me to discuss. Okay, other than week 12 assignment questions.
Ma'am, can we revise important what we say important in the last week for 1 hour from start to till end?
From start till end, revising everything in 1 hour
No,
will
no,
be an
just important touch.
exactly.
Then
So that's why I'm telling you that whatever you feel that you need revision for, you send me an email. Okay, so I will collate everybody's request and try to go through all those things.
okay, ma'am.
Yeah, because whatever I feel may be important may not be like useful for all of you. So I don't want to do that. Whatever you guys want to do, you just let me know, and I'll also try to put in something that has not been picked up by anybody, but I feel that may be important. Okay, so thanks a lot everyone for attending the session. We can meet next week 6 p.m. Thank you.
Ma'am,
Yes, tell me.
ma'am, please do one thing, that please confirm regarding the previous weeks, because they have uploaded the assignment answer also, and they have just have done the opposite of formula that you told. So please just check on that. No?
Yes, I'll do that.
Yeah. Thanks.
Thank you, ma'am.